This meeting is being recorded.
Yeah. And so we'll record the introductions too.
Okay.
And where stuff's not done or it's pending, point that out. If you have any questions, we can cover them. So let's make it real interactive. Maybe I could introduce myself just for 1 minute first, and then I'll let you guys take over. How's that sound?
Okay.
Yeah, sounds good. All right. So I was born and raised in Downers Grove, Illinois. Spent most of my high school and college time close to where you guys are. I'm a engineer by training. I went to MIT undergrad, Harvard Business School for grad school. I'm basically a software high-tech person, retired now. My wife and I live in Santa Fe, New Mexico. I'm a level 3 flyer. I'm the prefect as well as the president for our club in Albuquerque. It's called the Albuquerque Rocket Society. Yeah, I've been flying high power for some number of years, and I've flown a lot of rockets that are kind of like what you guys are building. So hopefully we can work together and make sure you have an incredibly successful flight and win the competition. So any questions about me?
Very cool. Very accomplished.
Okay.
I'll go next. My name is Daniel. I am a freshman here at UIC. I am not an engineer. I'm actually I'm in the urban studies program because that's what I want my career to be in. But I did NASA SLI as a high schooler for 3 years from 2020 in 2020, 2021, and last year in 2023 when I led the payload team. So I can join this club, but I only became like a manager position in in the second semester, so halfway through the year. So I was playing kind of just had to scramble and pick up wherever was left off.
Great.
But I wasn't allowed to get certified because I wasn't over 18, but I do have experience, so I generally have a good feel of, and like I've done it before quite a bit, like high powered stuff, but not at level 3, which is what we're doing with this.
Mm-hmm.
Anna, do you want to introduce yourself?
Yeah. So I'm Hannah. I just sophomore year as a physics and mathematical computer science double major. I joined this club last year on what was our experiment team for our payload. Unfortunately, it didn't end up going, so that didn't really happen. But this year, I was manager with Daniel, and then next year I will be the president of the larger organization.
Sweet.
I'm John Williams. I'm actually an aircraft mechanic for Southwest as my profession. I got my bachelor's degree in aviation maintenance at Lewis University in Romeoville, Illinois, and I grew up here in Illinois in the south suburbs in University Park. I started flying rockets when I was about 8 years old, 6 years old, something like that. And then I did Team America in high school. We did the Team America Challenge in high school, and then I got into high power after that. And I spent a term as a quartermaster for Quad Cities Rocket Club. I was a quartermaster officer for them. And I've been helping out with the U of I team. I mentored the U of I Champaign team at last year's Spaceport and the year before that. This year I'm with UIC as well as U of I Champaign for FARS.
Great. And you're going to be at the competition?
Yes.
Sweet. Well, we get to shake hands when we get there. So my wife and I are loyal customers of Southwest, and We fly all the time, and my wife is my companion, so she flies free with me.
Nice.
So keep those planes in good shape.
Oh, we always do. We try our best.
Yeah. Okay. So want to show me your rocket?
Yeah, so we'll start from the top. We're at varying stages. We feel confident in being able to do stuff, but other times we're hampered by scheduling and UIC not buying stuff. And we'll elaborate that as that comes. So here's a nose cone. It's a standard Wildman, Von Karman fiberglass nose cone. Aluminum tip. It has the screw inside that's holding the up here. There's the fiberglass washer up top. We haven't replaced it. And then most of the rocket is held together with these 1/4-20 combination screws. So we're gonna disassemble that. And then what's holding these screws in is these PEM nuts from McMaster Car. And we drilled these holes with, so you can check Hannah's phone if you have it open. We've drilled the PEM nuts with the McMaster Car, like special bit and everything, so the hole is very round and they're all mechanically secure. So on the inside, we've also put epoxy just as extra reinforcement.
So they don't fall out.
Yeah, and this is the nose cone shoulder. So it's 5 inches into the nose cone and 6 inches into the body tube as per the regulation.
Sweet.
So that's
Looks
pretty
good.
fun. So then our rocket has so I'm calling, there's the upper section, which is above the avionics bay, but this is split into 2 sections. The upper section near the section closer to the nose cone we're called the payload section, and the section under that I just call the upper section because I'm uncreative. So this is our payload. It is a boilerplate, so it matches the CubeSat regulations.
Is that the forward end of the payload section?
Yes. So
the coupler for the nose cone slides around the outside of that assembly, which is inside there. Yeah. Okay, great. Got it.
Yeah. So it's made of laser cut plywood to the exact dimensions, and we're gonna load it with weight and the inside, and then the rest will be epoxy. So there'd be no movement inside of this. It will just be a solid block of 8.8 pounds. So continue.
Do you have a way to ensure that it doesn't rotate during flight, or does that matter?
Yes, I was about to show you that. So inside here is
You have rails
three,
inside.
yeah, rails, and there's actually a little gap, so the coupler slides behind the rails, so the rails will not flex at all in flight.
Nice.
So and then there's a thick base with holes so that we can tighten the U-bolt under here. What will be located inside of here, because we are unable to get some parts until literally this week, is the plate where a nose cone GPS will sit, and then also a spacer under that bulkhead to stop the payload from sliding forward at all. And since this can all come apart, we'll be able to access the payload. But then in flight, when all put together, the payload won't be able to slide forward or backwards. And we can show you that. That's another.
So you have a featherweight GPS?
Yeah, we were planning to use an Telemega, but team members dropped out and I didn't have the time to get a ham radio certification.
Yeah. Do you have like the little plate you're going to mount it on, or are you still working on that?
Yeah. We have it set for the but it will just be a standard fiberglass bulkhead that we'll drill and then put a spacer on. There's not going to be much on it.
Are you going to mount it so that the antenna is like facing up and so the patch antenna is pointing sideways, or are you going to mount it flat on top of that?
Is it a problem if it's not mounted like this? Or because we were just planning to just have it like that.
Okay, so you're going to lay the battery, and you'll have some sort of a switch or a connector that you use to turn it on.
Yeah.
I don't think it's a big deal. You're not doing real high altitude. There's a tiny bit of aluminum, but it's way up above.
Yeah,
So I
I mean,
think you'll be okay.
the other place we would put it is the avionics bay, and that's full of metal because we're doing
Yeah.
CO2. Yeah.
So I wouldn't have any concerns about it myself.
Okay. And then the U-bolt at the bottom here, which I cannot view, is a half-inch black oxide U-bolt from McMaster with a breaking weight of, I think, working load of 2,000 pounds, or what it says on the website. It's epoxied in, but it's actually epoxied to a ring first. So this ring that you can see on the inside provides extra surface area, because one of the concerns John brought up was he didn't like it just being held in with just a fillet. So then we had extra, we put in a ring right under it. So it has a lip. It's like a reverse avionics bay lid. So there's extra surface area. And if needed, if there's a safety concern, we can also put screws into it.
It's basically a coupler that the bulkhead is sitting inside of, so that the bulkhead, the coupler provides surface area to the body tube so that so it provides additional surface area other than that, just that single fillet around the bulkhead.
Yeah. And it's a single piece of G10.
Yes, it's 5/16, the same material art fences.
Yeah. And do you have some washers on the other side of it, or
Yes, it's a plate. You might not be able to see it, but it's a plate that came with the U-bolt, so it stretches between.
Okay, so the plate goes between the two pieces of the U-bolt.
Yes.
Yeah. Okay. Got it.
And then there's the holes up top for the screw to go through, and then the bottom we don't have shear pins drilled yet because, in my experience at least, when you drill them too far ahead, you have problems aligning them on the launch site, and you often end up re-drilling them. But that might be like a procedural issue.
How many shear pin holes do you have?
We're going to go for 440 shear pins because that was what was recommended to us in the progress report too.
So if you have a tiny bit of extra time and you want to add a feature which maybe could make it a little easier for you, what I sometimes do is put a little alignment key at the joint, so that when you slide the tubes together, it goes to the point where everything lines up, and then you put screws in. And you can do that with a little bit of epoxy, or you can push a little metal or a carbon fiber dowel in.
I notch my tubes with a Dremel. I just put a small notch about in the tube. I don't cut off. Just make I etch it on the outside of the tube.
Okay, another good technique. So then you put your fingernail in the notch, and it's lined up. But
exactly.
Okay.
When your hands are shaking and it's windy and dusty, it's hard to get those shear pins in.
Okay? Absolutely. I recommended more shear pins because my concern was with the payload bay that they're using also incorporates underneath their payload bay sits their parachute bay, their main parachute bay. And because of the weight of the payload being at almost 9 pounds, the weight of the payload is going to, when that drogue deploys, you're going to have a lot of momentum. So that's why I recommended going with 440 pins as opposed to just 2 or 3, because I'm concerned that due to the payload weight and the momentum from the deployment, I didn't want the shear pins to blow in the process.
I agree. I would agree. If it was me, I would fly with 4 440s.
Right.
It's just for a 6-inch airframe, heavy weight up front. I think that's prudent. Okay. So do you have a vent hole in that compartment?
No, we haven't drilled that yet, but we don't think that should be an issue. We did not forget about the vent hole. We were going to, because we just wanted to make sure it wasn't obstructed by anything when we were to pack our parachute, because our lower section, that's not our main
Okay.
bay.
So you're gonna put like an 1/8 inch hole or something like that.
I would go 1/4 inch myself, but that's me. I like my vent holes big.
Yeah, or you could put a couple of, like 3 1/8 inches.
Yeah, that's fine.
You know,
Yeah,
that
that works
that
too.
way, if you're worried about, something getting in the way.
Here's our payload bay. So you can see the coupler up here, the U-bolt, whatever up here from the payload section would sit up here. And our parachute base is very unremarkable. It's same thing as a nose cone. PEM nuts under here in the coupler. It's 13 inches, so there's 6.5 on each side of this coupler, this internal coupler. You can see the PEM nuts inside.
Yeah.
And that's about it. It's a 6-inch tube. It's 19.5 inches. We got cut and then sanded down to that. And
So
then,
That's the parachute bay,
yeah,
right?
So refresh my memory, since it's been a while since I looked at your open rocket file. There's an open compartment with the U-bolt at the top that you showed a little bit ago, and there's a parachute in that section below the U-bolt.
yes. So if this is, so if our avionics bay goes under here,
Yes.
goes on this section, and our coupler is up here, then the open section will be above here.
And is that the main parachute or the drogue parachute?
The main will be thrown on the top.
Okay.
But the main shock cord sits inside here.
Okay. And what main did you select? How big is it?
It's a 96-inch Iris Ultra. We initially selected that chute because we saw in the club that we had one, and then when we later examined it, someone had cut all the cords off. Like the bridle was disassembled, and then we just ordered another one.
And is it in some sort of a bag, or are you gonna Z fold it and wrap it?
We are going to Z fold it, and
They're using a CO2 deployment, so they don't need
Yeah.
blankets.
Have you guys practiced folding that chute before?
yes.
Okay.
I've already, like, it was also because I was with the large size of the U-bolts. We were like, I don't actually know if this is gonna fit inside the rocket. So, because we had like an emergency option, because our coupler was 13 inches, we could add like an inch of space with a switch band, right?
But
So
everything fit.
Yeah, so it's all both packed into 8 inches.
Okay, great.
Right, and then here's our avionics bay. U-bolts on either side. I've not drilled the switch holes yet, but this is our switch band. It uses a 5/16 lid, which has a step inside. It uses the quick links. These quick links are U.S. stainless. They're rated to 3,000 pounds. Labeled on it. They're 10 millimeter. Same thing with these swivels, and they're using the Eagle CO2 system, and 2 on each side.
How big of a cartridge are you going to use?
Initially I was gonna go for 35 gram on both sides, because he said the manual said use the black powder charge calculator multiplied by 5.
Yeah.
But then when I initially done it, I set my pressure to like 12, and I think that might have been an overreaction. So for the upper section, we'll be using a 23 gram charge, and then for our lower section, we'll be doing a 35 gram charge.
Just my 2 cents on this. I think you're probably okay with 23. I've flown with those Eagles a lot.
Okay.
But you could, for your backup, put
do
larger
35.
cartridge
Yes.
in, and do the same on the other, just so that you sleep better at night.
Yeah.
So my experience has been that even if you go a little too high on CO2, it's not like black powder, and you're
Yeah,
not
it's not
going to
gonna, it's not
blow
like
the airframe out. Um, I'm just a tiny anecdote. W- a team of guys that I fly with, we've been flying a Q motor project. It hasn't successfully got over up to 107,000 feet, but we've flown it twice, and it uses Raptors instead of Eagles, but I mean it's basically the same thing.
Mhm.
And although I charge tested it with 45, I flew it with 75-gram cartridges because
Wow,
the fit, and I've had no problems. And we used 440, actually on that one, 6 440 shear pins.
Mhm.
So even if you go a little high, I don't think you're going to cause any problems. And if you did have any binding or what have you, that might just give you a little extra margin of safety on your backup. So
Yeah, we kind of figured the same thing because it's not black powder, but also because there's a lot of complaints online, like anecdotes about, oh, like CO2 is finicky. You have to make sure all the gas pressure builds up, all that. Not like, but it seems like from your experience, that's not truly the case. Sorry.
in the end, you do have to ground test it, but
Yeah.
I'll bet it'll open with 23. But if it was me, I would do 23, 35, and then 35, like 45 or whatever.
Yeah, I agree. I would step up on their backup. I mean, I even do that with my black powder chargers typically. I
Yeah,
step
I go
up on
about
my
20,
backup.
20%
I'll go,
or so.
yeah, I'll go big on my backup charge because at that point it's either open, it either opens or the rocket hits the ground. And if the backup fires and the parachute's already out, then it's gonna be fine anyway because it's just gonna dump the pressure anyway. It's not gonna hurt anything.
Yeah, it doesn't matter. So um could you just show me the ends of the av bay and the area of the switch band you intend to put the switches in, just so I can see it a little more clearly? I saw the big picture, but just maybe
The switch band or the lids or everything.
both. Can
Okay.
you just show me the lids?
So here are the lids. We've had these. I catted everything and had it machined
Okay.
out. So we're using.
Are you going to put terminal blocks on the other side, or how are you going to route the wires to
Yeah, so that's what we're waiting for. We were gonna wait. We were waiting for no barrier blocks as IRIC regulations require, and the USC didn't buy them for 3 weeks, so we're unable to work on it. We did have some bare components, so we already figured out the wiring and we did some of the video.
Are you going to use dual match charge cups or single match charge?
We asked asked the Kinder Rocketry guy, and he said use two, so we'll be using two.
Yeah, I typically fly with two if I have enough terminals on the altimeters.
Yeah, we're planning to fly two, so you can see with what little components we did have from what we could find around the club.
Okay.
This is just like an example, but here's
how are you going to mount the batteries on that?
The battery. This is a 18650 battery holder.
Yeah.
And yeah, it's mounted away from the acceleration forces. We're gonna throw paper right under that little slug right there to stop it from further compressing, and then mark and then very clearly identify which is positive and negative.
Are you going to zip tie it down or anything?
Yeah,
Yes.
I would.
Yeah, I wouldn't fly with just a box like that.
Yes.
You either electrical tape it and then mount the box down with zip ties, or zip tie it, but don't deform the battery. But
yeah, so this case is already epoxied down, and then the battery itself will be zip tied.
Okay.
Everything on here is already mechanically fastened with screws.
You just have to be careful. If something goes wrong, you would be amazed at what will break.
Yeah.
So
I would drill holes through the board on
exactly.
each side of the holder, and then you can run zip ties through it. I would just do 2 zip ties there, and that way the battery can't come out of the holder. And it also keeps the holder secured to the board in the event the epoxy gives on the holder so that the battery doesn't go flying around inside the bay.
Yeah, and then you could put a little bit of like foam padding under the battery so the zip tie doesn't, cut into it. There's a bunch of ways you can do that, but I would definitely use big zip ties, just as John said.
We're using for holding up the avionics space 3-threaded rods, and then but they're offset from the center, so we also have the option to add in. Sorry, let me show you a lid. So
the wires that go into the terminal block there, are you putting ferrules on them or are you tinning them? How are you treating the wires at the ends?
I think they're already the wires we bought or planning to use are already tinned.
Okay. So be careful that you don't end up with stranded wire going directly into a terminal block.
Yeah, these will be replaced with a barrier block because this white right here is replaced with a barrier block. The only terminal blocks will be used is connected to the e-matches.
Okay.
Yeah. Although technically, I think in the critical wiring guidelines, it's like the only wire that can be used is stranded wire unless it's on an e-match. And then it's why?
Yeah.
So
I was gonna say I thought they required stranded wire on the avionics boards, unless it was an e-match. They require stranded wire.
Yeah, I think so. And typically I'll tend to put a ferrule on it so it doesn't, break. Okay.
All right. So this is our
All good. And show me the switches. How are you going to do those?
Oh, so there's screw switches that we had found, and luckily because they're out of stock everywhere. So, but they're just normal missile work screw switches on the side, and then if the wall for the avionics bay is here,
so you're going to drill a hole big enough to access that.
And then we can, since the other screws are backwards, we can only screw one screw, and then we will confirm they're on because the Blue Raven has a smartphone app.
So you're flying 2 Blue Ravens?
Yes.
Okay.
We don't have a launch controller in the club, so it was great for us that the Blue Raven had the ground test capability.
Yeah. Have you configured your Blue Ravens yet?
Yes, they've all been programmed correctly.
Okay, good.
Yeah, otherwise, yeah. So like this wouldn't pass IREC guidelines, like because they're supposed to use like a jumper or whatever, and then we're still waiting on the school for that. But yeah, unfortunately, we're just waiting on the school, and we couldn't ground test even if we wanted.
Great. So what kind of a drogue will you have below this?
I asked online for a strong drogue because I was very aware of. So in our simulations, I already inputted like 15-mile-per-hour winds. And talking to John, it seems like that's like a good choice because it just winds are high out in the desert. So I looked around for a strong drogue, and we chose a Recon Recovery 24-inch drogue from Wildman.
How big is it?
24 inches.
And how fast do you think it'll come down feet per second? Do you have for that?
104, I think.
Okay, so pretty fast.
Yes.
Okay.
But yeah. Worst comes to worst, we can order a larger drogue from Fruity Shoots or something.
I'm a fan of smaller, not larger, but
yeah, I was because drift in the desert. I was like, nah.
Yeah, you'll be fine. I think you're fine as long as you keep it under 150.
Yeah, but yeah, the Recon Recovery looks really strong. It's got the big 4 Kevlar.
Yeah, 104 is about as fast as I'd like to see, though. I wouldn't want to see a whole lot faster than that. Me personally, I'm of the slower, not faster method typically, but yeah, I agree. Given the circumstances of the desert out there, drift is not your friend.
Yeah. Okay. Do you have the booster section you can
Yes,
show
it's
me?
in the other room right now.
Okay, so before we go to that, how about recovery harness? Have you got any of that you could show?
So that we have a it's from One Bad Hawk. It's a 3/4 or 1 inch. I'm pretty sure Kevlar, tubular Kevlar. It's got 2 loops on it. It's 540 inches, and we're using about 4 times the length of the rocket, and we're using that for both our main and drogue. There's 2 separate cords of identical spec.
So is the main connected like a third of the way down the
Yes,
shock
John was going to
cord?
space them
So
out.
it's a 3-loop One Bad Hawk.
It's only a 2-loop one from what we have here, so we'll have
Okay.
to cut knot.
So it's got 2 ends, and then it has like a little connection point in the middle.
Yeah,
Or
we'll have to
knotted.
Just nodded.
Yeah.
Okay.
Yeah, I mean, you have it right there, don't you, Daniel? The harness, you want to grab that?
Yeah, can you just put it on the video for posterity? Okay, yeah, see it? So are you gonna like Z fold those and time them in little bundles?
Yeah. So this is when we were Z folding to test the path.
Yeah. Given you have a really heavy rocket, you might consider taping both sides of each bundle. Make each bundle about 6, but that's just my personal style.
Okay. Yeah, that sounds good.
It just they don't flop as much, but if you have tons of room, it doesn't matter.
Yeah. We'll take we can take them.
Okay. So the bottom of the rocket.
Yes. Hannah, you'll need them. Can you guys hear me?
Yeah.
Yeah.
Okay, so here is our booster section. John came and checked our tacks. We're ready. We're going to internal fillet them. So we're gonna we have US Composites thin epoxy. So that will be injected into here. We have a fin jig right there, which will help us glue it up. And then we're gonna do one section at a time. So these two, and then these two. And then for the external, we'll use the same epoxy mixed with silica, and then use a nice clean fillet. Obviously, we'll be taping all this off, so there's nice and clean and aerodynamic.
Do you have a sense for the radius of the fillet that you're going to put on the outside?
Yes, I think we're going for a 1-inch radius fillet.
Yeah, so it's bigger than 3/4. Okay, good.
And so they're gonna fill it on the motor tube side and on the airframe side internally. So
So both,
they're gonna fill it both sides, and then they'll have their external fillet. So it's actually 3 complete sets.
Yep. Okay. And then you're going to put the centering ring on the bottom, and then you've got a motor retainer of some kind.
Yeah, we have a thrust plate here. Yeah.
Okay, so you're going to screw that. So you have a thrust plate. Okay, great. So are you going to screw the thrust plate to the centering ring? How are you going to?
Yes, we're screwing the thrust plate into the rear centering ring. The rear centering will have nuts behind it.
Okay, so you're going to have like 3 screws or 6? Or
yes.
Like
yeah, so there's three screws that go through the thrust plate. Then there will be a nut that holds the screws in place against the thrust plate. The center ring goes on, and then there's 3 more nuts that hold the center ring on top of that. So it's like a sandwich, and then those nuts get epoxied on the backside so that they can't come out. And then that makes it kind of a permanent fixture. And then that whole thing snaps into the back of the body tube, and then it's epoxied. The center ring is epoxied both to the body tube and the motor tube in place.
Okay, makes sense. So at the other end, does the motor it's the body tube, is there a compartment or is it open at the top?
It's open.
The motor tube?
Yeah, like at the top of the motor, if you were looking upwards where the motor is, can you see out the top of the booster tube, or do you have, okay. So how are you going to mount the harness? Is it going to be on the
Yeah,
fold
so we're
closure?
gonna use the eyeball on top of the motor retainer. It's an Aerotech 10240.
Okay, great. All right.
And I think then we'll be using 1515 rail buttons, which we're still waiting for the school to order. But
Where did you buy them from?
Wildman.
Okay. So kind of standard. And what are you going to use to back and reinforce the?
Oh, weld nut.
So weld nut. So you're going to have to wait to put that centering ring in until
Yeah.
the very end, huh?
Well, so when I install my well nuts, I just cut the hole and install them from the outside because the well nut expands inside the body tube.
All right. Well, I never did it that way. Usually
Yeah.
I put them up the inside, but
No, I go in so I go from the outside, it goes down in there, and then when you thread the screw in there, it expands and it pulls it into place, and then that mounts it securely inside the body tube. I've always installed mine after the fact. I've never had a problem. And so my ultimate Wildman, all of my larger rockets have had their weld nuts. And that makes it easy to replace as well if the rail button breaks off, then I can just unscrew it and do it right there in the field.
amen. So are you going to paint your rocket?
Yes. We have all the spray paint.
Yeah, and then you're going to put your
Number, yes.
number and all that stuff. And you've got 4 shear pins on this joint as well.
So they'll be located here where it's the AV bay is.
Okay.
There's a lot of space, like relative, because we only have a drogue and the shock cord here. But this is just the size of the tube that it naturally was in, and it helped with our stability margin. If we were to optimize space, then our static stability margin would drop to an unacceptable level.
Cool.
I do have one question, and I should have asked Daniel this while I was out there, but I'm going to ask it now. Daniel, so just so I'm understanding correctly, the avionics bay sits directly on top of that booster section, and then above that is a section of a section that is your parachute bay.
Yes.
And that screws into the avionics bay section.
Yes.
And then how does that screw into or how does that join to the payload bay section? Because it seems like there's an extra section there somewhere.
I was thinking maybe the shear pins were up at that top joint.
The shear pins are here.
Okay, wait. So all right, so the parachute bay. All right, so where's the pit? So the payload bay. So that's the avionics bay, right?
No, this is the parachute bay. The avionics bay is not it's disassembled right now.
Okay.
It goes under here where it'll be screwed in.
Got it. Okay, I got it. And then it just sits on so there's just an extra section of tubing. Yeah, so there's just an extra section of tubing. Okay, I got it. That's all I was curious.
Because we need the rules require a coupler of length and prevent it from bending and all that.
Got it. Yeah, I was just curious. I was like, there's an extra section of bay here, and I was like, where is it? Yeah, I got you.
Okay.
It's kind of like the nose cone pops off.
Yeah.
So to speak.
It's like the nose cone has a big long section on top of,
Yeah, exactly. It's like a long nose cone.
Yeah.
So let me see. I'm just going to look quickly at my my checklist. We covered all the things that we could, given where you guys are. Just 2 other questions, 3 other questions conceptually. Do you plan to fully assemble the rocket and measure the center of gravity before you depart?
Yes. Well, yeah, we kind of have to, like, because then we're also
Good,
like safety
good.
review. And, yeah.
I advise that.
We truly were trying to aim for the test flight, and then a bunch of stuff came up, and I got busy. And essentially, it's even though there's more members on the team, I'm the only one on the team with a more extensive, high-powered knowledge, and although and then also the only person who would come in to work on it. So it's just
Cool.
team stuff.
So do you have the motor in hand, or are you waiting for it?
It's in Spaceport because I think what has happened is we placed our motor order well before the deadline, but when things were in stock, and then the school bureaucracy had problems having an L3 verified. So at that point, it was all to just order for the motor to be picked up in Spaceport.
Okay. So you're going to assemble the rocket and measure the center of gravity with the case in, but without the grains, basically, right?
We can probably load up the case with mass.
Well, the other thing that I often do is you can the equations to adjust center of gravity are pretty straightforward, but basically if you know the center of gravity of your vehicle, and then you say the grains are the weight that's in like thrust curve or on the vendor's website, and it's centered in the middle of the casing, you can adjust the center of gravity mathematically, and it'll be pretty accurate. So that could be something you could do before you leave, so you don't have a last minute problem, with stability margin, out there.
So because it has to be marked and everything with the numbers.
Yeah. Okay. Last thing, do you guys have checklists ready, or are you probably going to work on those between now and
we do have a standard basic checklist. It's like check your thing is on, but I think I'm gonna specify it, make it really clear, because I feel like typing them out and knowing what's going to happen versus being in the desert and forgetting something. But yeah, they were included in the technical report as
Okay, so you've thought about it.
Yeah. Well, so John also mentioned you also have to have them printed out, so we'll also have to do that before.
Yeah. And it's nice if you assign one of your team members to be the checklist process person, and they have a clipboard, and they actually initial each step, because sometimes in the flurry of getting ready, you skip stuff, and there's no one person responsible for the process. So
yeah, I think I had that exact same recommendation when I was doing SLI last year. They're like, hey, print it out, and then also make sure you have a dedicated person.
Yeah, and make sure they have a clipboard and a pencil so they can initial each step. Okay. I don't have any more questions. You guys have made a lot of progress. You have work to do. Good luck getting that all done. Be sure to do your charge testing.
Yeah. I mean, we won't be able to fly without it done anyway. So
yeah. Okay.
Yeah.
Anything you need from me, or are we good for today?
No, I don't. Yeah, I think we have a good idea what we need to do. Yeah, that's it.
Yeah, we did have a conversation today, me and Hannah and Daniel, about just things that need to get done as far as preparation, both between now and Spaceport, and also expectations when we're out there to try and streamline, getting out to the pads and things like that. I'm sure from years past, it can be chaotic out there and time consuming. So working on making sure that they are aware of what they need to have out there. So I think they have a good idea of what, is needed going forward. get this on track smoothly. So, I think they, and I've, obviously, Daniel, if you guys have any other issues that you run into, especially when you're doing your fielding or anything like that, let me know. I can come down and we can sort out whatever needs to be sorted out and get it going so that we can stay on track.
Thank you.
So just following on what John just said, I've spent a lot of time. We have my club has a high altitude launch site about 20 miles north of Spaceport, out in the desert there. We just
Like
flew,
White Sands.
yeah, it's north of White Sands. Basically, if you look on the map, there's a Stallion Gate entrance to White Sands. It's about 4 miles past that to the north. So we have a waiver to 65,000 feet there. So
Wow.
that's a fun place. We just flew out there on May 5th. A couple of techniques beyond the checklist. I like to have a small, like a small toolbox that has
Yeah.
everything that's needed to actually assemble the rocket, the shear pins, um, strippers for your igniters, the screwdrivers that you need to put your shear pins in, the switch, the screwdrivers for the switches. I like to have that like in the back of the car right up front. And then
Yeah.
I have a bigger toolbox with all the backup stuff that if something breaks or if I have to, make
Yeah.
a more fundamental repair. And then I've got the checklist plus my little toolbox. And then I like to pack my vehicle so that things are organized either left to right or front to back so that you know where to get each thing and you lay them out logically based on the order that you're going to assemble them, not the order that necessarily they pack the easiest. So for example, you're going to want to take your booster out, put it on a stand. You want to take the motor out. It's going to be in a anti-static bag probably or not, depending. Uh, you want to mount it, put the retainer cap on, connect the recovery harness, blah blah blah. So I'm just kind of talking, but I usually kind of lay things out to try to get my prep down, to 30 minutes max 1 hour. So you're ready to go.
Yeah, that's exactly what I was. We actually had a whole conversation about that too.
Hey,
And I said the exact same thing. If it's taking longer than an hour, it's too long. This, especially out in Spaceport, I expressed they need to have tools. They need to have spare screws for the screw switches, spare rail buttons in case one breaks, and have tape and have wrenches, screwdrivers, anything that you need that needs to be, and you need to have it in a little pouch or a bag or a box so that you can
yeah,
take it to the pad with you. So if something comes up, it can be addressed in the field. Because if you have to come all the way back to base, it may take hours before you get a chance to go back out. So we did have a conversation about that, and
right.
also about, just having organization during the prep phase so that it's not taking 2 or 3 hours to integrate the rocket. So
Yeah, and you might practice your checklist in your shop before you leave so that
yes,
it really works.
absolutely.
Don't practice it for the first time on the pad at Spaceport.
Absolutely. Yeah, and that was something else we talked about. It's practicing the integration process, rehearsal of the integration process so that, you can get it down, so you can get it down under an hour, so that you can actually do it in under an hour.
Yeah. Okay, John, you're my man.
I like to be organized, and I got to be out there with them, and I don't want to be out there in that heat any longer than I have to be.
All right. Well, good luck, guys. I look forward to getting together and spending time. I hope you have
Yeah.
great success. John, thanks for your help and leadership and pushing these guys in a direction that makes sense. And, go, 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 finish the rocket and make sure it's
Yeah.
ready to go before you pack up.
Well,
Brett,
I
I
thank
have one
you very
more
much, Brett. Appreciate all your insight and your time and you volunteering to help with all of these teams doing this too. So thank you for your insight and all of your help with making this happen. I know you guys this process relies on a lot of volunteers stepping up to make this happen, and I know it's often a thankless job. So
Yeah.
Thank you.
All right, man. I'm going to stop the recording, and then once it processes, I'll send it in. Given you guys are still working on your rocket, I'm not sure whether they're going to ask me to do another one or not, but let's just focus on getting your rocket done, not
Yeah.
on the process. And I'll be in touch if anything else is needed.
Yeah.
thank you
Brett,
so much. I appreciate it.
All right, have a
I have
great
one-
day.
I have one more question.
Oh,
Yeah.
wait.
Absolutely.
How would you recommend? Because we have quite a bit of structure, like epoxy, that needs to be like structural outside of the fins, right? How would you recommend keeping the rocket cool while we're prepping it? Besides,
What
like,
I do
paint?
is I bring white towels
Okay.
and I cover the dark sections of the airframe.
Okay.
I'm typically not worried so much about the booster as I am about AV bay and electronics, because you don't want to overheat your CO2 and the batteries and the electronics. So your nose cone is dark. Well, I don't know what color you're going to paint everything, but
Oh, probably mostly white.
yeah. But I oftentimes have a white towels
Yes.
or some white you could put a white fabric with a band to like a zip tie band or something to hold it.
What I've
Okay.
seen teams in the past at Spaceport do is they bring these it looks like it's a thermal reflective blanket. It looks like a piece of aluminum foil.
The
And
space blanket. Yeah.
yeah, and they bring those out and they cover their rockets with those because there is a lot of time in the queue where the rocket is going to be exposed to the sun. I know
Yeah.
like Brett was saying, I wouldn't be so concerned about the epoxy as I would about the avionics.
Okay.
The avionics and the batteries are the epoxy, honestly, in that heat. If you're using quality epoxy, it shouldn't be a problem. I would be more concerned about the avionics and the heat affecting the electronics more than the epoxy. Because once that epoxy is cured, it should be able to tolerate the sun heat just fine.
It should get to 120 degrees. It's not gonna.
Yeah, that's not going to hurt it. Whereas like
Yeah.
the avionics, your batteries overheat, your boards overheat, all that kind of stuff doesn't like that kind of heat. So like Brett was saying, towels, or like I said, I've seen teams use those space blankets, those reflective blankets.
Yeah,
They work
thermal
really good.
blanket. That's a great idea, and it's reflective. So
Yeah.
I never thought of that. That's a good idea.
Okay. Thank you. Thank you so much. I don't have any further questions.
Okay. Well, reach out to me by email if you do.
Thank you.
You guys have a great day.
Thank you.
Have a good day. Thank you. Bye. Thank you, John. Thank you.
Yep.